part of the reason why we've seen such incredible adoption of models like Palm 2 and then also the GPT-3 plus variants is because we've seen a really powerful increase in our ability to serve these models efficiently. And then also distillation techniques to make the same kind of performance that you might get from a model with hundreds of billions of parameters fit into a model with perhaps, a couple dozen. And that is really, really interesting to me because we don't want to wind up in a world where the only people who have access to these incredibly powerful tools are people who can afford to pay like a premium for accelerators. We should be trying to find ways where we can have really, really super powerful models, but with a much smaller footprint.
Hello, and welcome to the Cognitive Revolution, where we interview visionary researchers, entrepreneurs, and builders working on the frontier of artificial intelligence. Each week, we'll explore their revolutionary ideas, and together we'll build a picture of how AI technology will transform work, life, and society in the coming years. I'm Nathan Labenz, joined by my co-host, Eric Torenberg.
Hello, and welcome back to the Cognitive Revolution. Today, I am very excited to speak with Paige Bailey, who was the lead product manager on Google's Palm 2. Now, it's no secret that with the rise of ChatGPT, Google, which had always been a leader in AI research, both at its headquarters in Mountain View and via its acquisition and continued investment in London-based DeepMind, made a special push to respond by polishing and productizing its own large language model experiences. With this in mind, I just knew that Paige had been through one of the most interesting experiences of anyone on Earth over the last year or so. What's it like to play a critical leadership role in a mission-critical AI project at a company that has more AI resources, including data, compute, and algorithm expertise, simultaneously has more opportunity and more to lose than any other company in the world, and is fully focused on shipping AI as soon as possible? How do you pull the team together and unite the work? How do you even organize the data and reserve the compute? And what's it like to manage the development of a frontier language model in general? These products have more surface area than any previously created. And with each new generation, or should I say, with each additional order of magnitude of pre-training compute, we are finding all sorts of new, sometimes quite surprising capabilities. And then, what's it like to work with the rest of Google as that same core technology is deployed across dozens of products and begins to be customized for all sorts of specific purposes as well? These were just some of the questions that I had for Paige, and her answers did not disappoint. Comparing the project to the Apollo program, which is not really an unreasonable comparison, particularly if you consider the incredible data and compute platforms on which Palm 2 was built, Paige offers a truly unique perspective on the process of training a frontier language model in 2023. We talk about her early AI eureka moments, her responsibilities as product manager, how the team comes together to define how they want the model to behave, how many advances seem to be happening ahead of schedule at Google right now, how we should understand models' reasoning ability, and the special opportunity that citizen scientists have to contribute to this research, the AI products that she is most excited about, where the next breakthroughs might come from, and lots more. We packed a lot into less than an hour, and it was super fun. As always, if you're finding value in the show, we would appreciate a review on Apple Podcasts, Spotify, or YouTube. And if you'd like to contribute to the show, you can follow me on Twitter, where I am @Labenz. And I've recently started sharing my draft list of questions a few days before recording interviews. I leave the comments open so anyone can suggest additional questions. And I want to give a special shout out and thank you to listener Dave Neuer, who has recently contributed some very thoughtful questions of his own. Now, here's Paige Bailey, lead product manager for Google's Palm 2. Paige Bailey, welcome to the Cognitive Revolution.
Excellent. Thank you so much for having me, Nathan.
Yeah, I'm really excited about this conversation because you have had probably one of the most interesting last years of anybody on the planet, including your role as lead product manager on Palm 2, which is, for the moment at least, the frontier model out of Google, right? Google DeepMind. What's the deal there now? It's been merged. Is that merger fully done?
So yes, definitely it's been an exciting year. Palm 2, we announced at I/O. If folks are curious, they can go check out g.co/palm2, read the technical report, watch the video, etc. It's incorporated into honestly dozens now products and features across Alphabet's product surface, which is really exhilarating. I don't think I've been prouder of anything in my career than the work that the team did to kind of get the model ready, to get it tested and instruction tuned, and then incorporated into all of these great places. And then for Google DeepMind, that is also something that is super, super exciting. So historically, we had kind of many different research orgs throughout Alphabet, most notably kind of Google Research and then Brain embedded within research. I was part of Google Brain up until just recently, and then DeepMind under Demis Hassabis, also doing phenomenal research work, really groundbreaking things like AlphaFold, AlphaGo, like all of these super, super notable Nature paper worthy research efforts. So just recently, Sergey and all of the folks at Alphabet decided to take Brain, which was a part of research, and to take DeepMind and merge them together. And so far, it has been amazing. It's been so, so nice to have very open collaboration between researchers that had previously been, kind of separated just by result of being in a couple of different PAs. And I've personally seen, dozens of organic kind of collaborations just spring up in the past few months. So if anything, it's just been certainly the best thing from my perspective that Alphabet could have done for its research teams. And it's also been, just an incredible thing to be a part of, to be able to see all of these people begin to work together when they've wanted to for a long time, or they've already been working together for a long time just across PAs.
Yeah, it seems like the intensity, the focus, the output is kind of ramping up everywhere. I want to start off by just asking you a little bit about what it means to be a product manager on a product like a language model, like a PaLM 2, that has such insane surface area. I think a lot of people have a sense for like what it means to kind of manage a web product, and talk to users and like tinker and, make iterative improvements. But this thing is just so vast. I imagine it's quite a different experience.
Absolutely. And that's a great question. So I feel like my backstory, I started doing machine learning engineering, a long time ago. The first time I implemented a machine learning model was like in 2009 or 2010. So things have changed pretty rapidly. I'm also relatively new to the product space. So I just became a product human a few years ago. Up until then, I was doing engineering, either like developer programs, engineering sort of things within Alphabet, or being a machine learning engineer or a data scientist. And I think that helps you build an awful lot of empathy for the researchers and the engineers who are building and deploying these models. I also feel like I could never be a product human on anything other than a technical product, whether it's developer tools or a model that's being built in research, because I still get to program every day. And if I couldn't program every day, I would be a very sad person. I will say that for large language models in particular, to your point, as you're building them, there are so many things you have to take into account. So there's both the pre-training data mixture for building a large language model or building a multimodal model. So you have to care about things like compliance, but then also how the model might be used downstream. So all of the ways in which users might be sort of asking questions or wanting to get feedback, those data or data that sort of would address those questions has to be incorporated back into pre-training. So you have to have a lot of intuition about how models will be used, or you have to be doing kind of very rigorous data analysis on all of the deployment surfaces on which the model has been deployed. Relatedly, you have to have evals to make sure that the model is kind of behaving in the way in which you expect. And these could be anything from like responsible AI evals to capabilities evals. So does it generate code well? Does it explain code well? Does it do security vulnerability detection? Can it solve math problems? Like all of these various things. And then you also need to think about instruction tuning data sets. So once the model has been pre-trained, how do you kind of fine tune it in such a way that it can give zero-shot answers as opposed to few-shot answers? How do you think about deployments? So the different model sizes, what are the constraints there in terms of latency? And that's also very, very related to how people might be using it downstream. And then also considering things like RLEF or RLHF on how you might incrementally improve the model over time. So it's an entire spectrum of things. And in order to do it effectively, especially now, you have to be really, really invested in all of the use cases in which your models are being deployed. I think it requires a special kind of person to care about it, because I am so impressed with other PMs that are so effective at like finance or design for websites, or can like place the button in the appropriate place. But I am not one of them. And so the skill set that I've developed as an engineer, I think is useful in the sense of being a research PM. But it's not necessarily something that's for everybody.
Yeah, that's just a few considerations to take into account. I'd love to hear kind of the maybe origin story of this project and a couple different angles on that you might unpack. I was just talking to Vivek Natarajan from MedPalm 2 and now Multimodal MedPalm yesterday, and really struck by how compressed the timeline is on those projects. He always emphasizes we're standing on the shoulders of giants with infrastructure and obviously prior research results as well. I'd love to kind of hear to the, not like into super specifics obviously, but kind of how long was this thing in the works? Was it basically concurrent with GPT-4? How does a project like this get started? How do you decide, because this is obviously presumably one of the biggest compute allocations Google's going to make. Like, how do you decide how big the compute budget's going to be? Do you have like your sort of Palm 2 moment stories where you got this thing back and you were like, oh my God, this is actually next level? What's kind of the journey that you went on to ultimately bring this thing out to release?
It is a very, very significant compute allocation, which means that, you do have to kind of convince many different teams throughout Alphabet to kind of okay the utilization of TPUs. That also falls into a lot of the product management questions. So if you're building a model, how do you make sure it's a model that can be used by as many different teams all at once? And that it doesn't have any compliance concerns, that it doesn't have any, stickiness around data. All of these things are super, super important. But for the Palm 2 story, I think, Google's been building generative models for a really long time. And we've been announcing them at I/O for a long time. I think this is the first time that we announced one with like over 25 deployments already, though, at I/O. So as an example, BERT, the original Palm, Palm 2, and now with Gemini, we're thinking increasingly about how do we get these models out into the world. And so to your earlier point about standing on the shoulders of giants, being able to use data sets that other teams have aggregated, open source data sets that might be different kind of pre-processing techniques for open source data, being able to kind of leverage the model architectures that folks have kind of deemed to be the most impactful, and then really mobilizing this incredible team across many different parts of research together to do the data aggregation, to train the model, to figure out what architecture and what kind of tokenizers should be used, to kind of babysit the model over time, because you do have to monitor it to make sure that it's continuously training. It does like have problems every once in a while, and you have to restart it or rewind and like go back and like make sure that everything is going correctly, and then doing the final stages of polishing to make sure that it works well. So it really is just this massive, massive effort. It feels an awful lot like working on an Apollo program to be training one of these models. That's something that, perhaps there's not a strong understanding of externally, is that not only do you need massive amounts of compute, not only do you need massive amounts of data, but you also need a really strong team with a lot of expertise in different areas in order to do these things effectively.
So does that make you effectively a kind of manager or a information hub, or like the first user, who is kind of responsible for like, is this thing working well or not, or maybe all of those?
I would not call myself a manager in the sense that there are TLs responsible for each of these work streams, and they do an incredible job of both defining the work that needs to happen, and then holding folks accountable, reviewing CLs, though sometimes I review CLs. But I will say, being able to coordinate between all of the teams, making sure that they're all heading in the same general direction. If one team comes up with an eval, making sure that we haven't included any of those eval data in the pre-training data mixture. And then also like being tied at the hip to whatever latest version of the checkpoint we have to constantly be testing to make sure that we're improving on all of the areas that we want to improve. Those are parts of the day job.
Hey, we'll continue our interview in a moment after a word from our sponsors. If you're a startup founder or executive running a growing business, you know that as you scale, your systems break down and the cracks start to show. If this resonates with you, there are 3 numbers you need to know: 36,000, 25, and 1. 36,000. That's the number of businesses which have upgraded to NetSuite by Oracle. NetSuite is the #1 cloud financial system, streamline accounting, financial management, inventory, HR, and more. 25. NetSuite turns 25 this year. That's 25 years of helping businesses do more with less, close their books in days, not weeks, and drive down costs. 1, because your business is one of a kind, so you get a customized solution for all your KPIs in one efficient system with one source of truth. Manage risk, get reliable forecasts, and improve margins. Everything you need all in one place. Right now, download NetSuite's popular KPI checklist, designed to give you consistently excellent performance, absolutely free, at netsuite.com/cognitive. That's netsuite.com/cognitive to get your own KPI checklist. netsuite.com/cognitive. OmniKey uses generative AI to enable you to launch hundreds of thousands of ad iterations that actually work, customized across all platforms with a click of a button. I believe in OmniKey so much that I invested in it, and I recommend you use it too. Use CogRev to get a 10% discount.
When you talk about all these teams, one thing that I was really wondering about, because I've seen this writ small in organizations that I help with AI, where sometimes it's like, you try to do some AI task automation. And one thing that can come to light is that the organization doesn't necessarily have a clear sense of what it wants out of this task. Somebody's just kind of doing it, or maybe multiple people are doing it. They might be doing it a little bit differently. And now when we're actually going to evaluate an AI, it's like, well, actually, we never evaluated the people, so we don't really have a standard of what is good, and people can disagree. How did you even think about the process of, presumably as a team, coming together to say, this is how we want Palm 2 to behave? You could write, obviously, almost infinite instructions or wishes for how such a big system would behave. But how did you guys think about even getting your arms around that in the first place?
So that's a great question. I think that there are many different teams that might define personas for how they might want the model to behave downstream. So as an example, Bard, the Bard landing surface has a persona associated with the way that the model is presented to a user. And you might have a different persona if you're providing code assistance within an IDE, or you might have a different persona if you're the MedPalm model or any of these other domain specific models. So that's something that we tried to create a general purpose instruction tuned model that's generally useful for kind of as broad a variety of use cases as we could. And then really each other team is responsible for defining how they want that model to be a helpful tool for their users. So I will say that a lot of work goes into that process, immense amounts of work, both for that as well as for instruction tuning to kind of nudge the model towards certain behaviors. And I think alignment work as well is one of the most interesting things that we do now as foundational model teams. There's been great work from Alphabet and then from many other folks out in the industry. I particularly love Anthropic's papers on AI alignment.
I mean, it's crazy. That's all basically in a year, right? Because I think April 2022 is Palm 1, now Palm 1 publication, and May, I think, right, for Palm 2 official kind of announcement. So in that window, you've got to figure out, okay, what's this next generation going to look like? How much bigger is the data set? What are we going to augment on? You've got to do all of the kind of experimental work to satisfy yourselves that the giant training run is actually going to work. You've got to talk everybody into the compute and get all that lined up.
wrangle the people, decide what model sizes should be, decide what kind of domain-specific models should result, do the instruction tuning, help the PAs with the deployments. It was an awful lot of work, but it was so, so energizing and I think empowering for the team as well to be able to have, like Sundar and team stand on a stage and say like, guess what? Like this model exists and also it is in over like 2 dozen products and features already. Congratulations, you're using it. So that's an incredible thing. And we've never been able to do that as Alphabet before.
Yeah, there's obviously been so much, talk about has Google lost its ability to ship, or is everything too bureaucratic there? This would be a pretty strong counterpoint, I would say, to that narrative, because this is not a color change to a button in Gmail, right? This is it sounds like a whole layer across the entire company at this point with all of its bazillions of products. Has there been a moment? I mean, I guess for starters, like, do you think that narrative was ever true? Was there a time when there was kind of a shipping paralysis, or was that all just kind of nonsense?
I've always been impressed with the number of features that we regularly ship, and I feel like perhaps they might be features within Photos or features within Gmail or updates to algorithms within search or whatever it might be. They might not be so immediately obvious to an end user, but it's still incremental improvement, despite not being, launching multiple new named products all the time. So it's also interesting to consider the dichotomy of like, oh, well, Google's not shipping, but also like, wow, Google ships a lot of stuff. They have like 3 chat apps or whatever. It seems just like a little sort of cognitive dissonance. Like, how do you wrap your brain around it?
My general sense is that narrative has kind of always been a bit overstated. And the big thing that I kind of keep always in mind too, and I was telling people quite a bit, was like, let's see. In the immediate wake of ChatGPT, right? It was like, where's Google on this? They invented the technology. They should have been here. But I was kind of like, yeah, but keep in mind also, it's only really recently become useful at all. It's not like GPT-2 was doing anything for anybody really. So it's an interesting, artifact, and it's cool to study, but it doesn't like really move the needle for most work, right? So it's not really something that would naturally have been deployed, and it probably would have just kind of been weird, if you had put it in a bunch of products. So I was always kind of betting on you and the team, not knowing anybody, individually super well, but just feeling like the quality of the research that I saw coming out suggested that there was not any, any systematic slowdown or weakness.
And we have, we've been a machine learning first company for a very, very long time. So AI integrated into pretty much everything that we do. But to your point, there were usually models that were a bit simpler, easier to serve. And I think part of the reason why we've seen such incredible adoption of models like Palm 2 and then also the GPT-3 plus variants is because we've seen a really powerful increase in our ability to serve these models efficiently. And then also distillation techniques to make the same kind of performance that you might get from a model with hundreds of billions of parameters fit into a model with perhaps, a couple dozen. And that is really, really interesting to me, because we don't want to wind up in a world where the only people who have access to these incredibly powerful tools are people who can afford to pay like a premium for accelerators. We should be trying to find ways where we can have really, really super powerful models, but with a much smaller footprint. So they can be served on a CPU or they can be served really efficiently on a single accelerator. And that I don't think that would have been the case up until just recently.
Yeah, it's amazing how much progress there has been on that, chinchilla scaling laws, and it just seems like it, at least for now, has kept going. Did you have any eureka moments, not in the sense of like discovery of how to make it work, but just how well it was working? Like I have my I was a GPT-4 red team participant. And at the time it was like a lightning bolt, out of the clear. And I was very into all the existing models, right? But the leap between what I had seen and that at that moment last fall was like, oh my God. Everybody who I've talked to has had kind of a similar story, but I wonder if you have a Palm 2 version that you would tell.
So I actually think this happened for me when I was working at GitHub. So when we were testing out Copilot, like the very first instances of Copilot, there had previously been, and I'm a nerd for developer tools. It's like they are amazing. Like hugest, biggest, always fan of VS Code. If you ever want like pointers on creating an extension, I am happy to always give ad hoc advice. There had been tools for code completions earlier, so something called IntelliCode, as well as other tools that were available on the market, like Tab9, which was using kind of GPT-2 under the hood, and you could get somewhat decent completions, single line, 2 to 3 line, dependent on the language that you were using. If you were using Python for GPT-2 based products, you were probably getting pretty decent answers. If you were using Python with IntelliCode, you were probably not getting decent answers because it did much better on C# and .NET stuff. Looking through that user experience and then seeing kind of what happened just out of the box with the Copilot extension, where you were getting like 5, 6, 7 lines that were generally good lines of code, that were related to what you were asking. And even, like text, being able to help plan out an itinerary for a weekend in San Francisco, it was bonkers. Like just thinking through how this would impact developers long term, and sort of, it was still early stages. So like trying to do prompt engineering just in the context of the signals that you send to the model, it was transformative. And all I could think was just like, all right, like this is going to be insane. This is going to impact everything that we do. And as soon as that happened, I was just like, okay, like there's building the model, that is the only thing I want to do with my life, like making it much, much better at generating code, generating math, because I really do feel those are the things that will move the needle the most for progress going forward in the generative model space.
I can relate to the Copilot story. In the interest of time, I won't tell my version of it, but I definitely recall a Copilot where I was like, "Oh, that would have taken me a long time to figure out." It's funny. I'm just old enough to remember, and was kind of a young adult at the time when Google came out, and I remember people being like, "This is incredibly next level." And it does feel like we've kind of hit another thing where it's like, yeah, I wouldn't have wanted to search for this. It would have been a bit of a struggle, but boom, it just kind of nailed it. There's kind of several frontier models, right, that are out in the market today. And I wonder where you think we are in this story. GPT-4 gets most of the attention because it kind of came first and still kind of edges out the others on, the leading benchmarks. How would you characterize the comparison between a Palm 2 and a GPT-4? Maybe you could throw a Claude 2 in there or a Llama 2. Like, I'm not sure how you think about the relevant set of comparisons. And also, I'm really interested in how much do you think that matters? Do you guys think about, competing specifically with other models, or is that less relevant to the way you're approaching the work?
I think that everyone is doing wonderful work in this space, and it's very exciting to be here at the front lines for generative AI as it gets incorporated into product. It's also really energizing to see so many open source offerings spring up and be capable of being used for folks that are wanting to try out things within their projects, but then they might not have their needs addressed by just a kind of commodity REST API. So I've particularly been excited about the applications of Llama 2 because you can do continued pre-training. You can do more into the weeds style optimizations than you would be able to do with something that you could only access via a REST API. I do know that we are focused on continuously improving all of the models that we've built and making them better and better over time, both by improving our data sets, by exploring these RL techniques, as well as building bigger and even more powerful models like Gemini. And for folks who might not have familiarity, Palm 2 was kind of a text and code based model. Gemini is multimodal from day zero. It's a superset of Palm 2's capabilities. There's immense potential impact for all of these models to have in the world. And I also think that as people are selecting models for their use cases. They might want to explore different latency approaches. They might want to explore different model size variants, but there's certainly much more room in this space to grow.
Yeah, it seems like if you zoom out, the kind of leapfrog of who exactly, passed who on what benchmark at any given time probably fades into the background and doesn't matter. If you try to try to envision a 2025 perspective, it's like all those considerations, become kind of footnotes in history pretty quick, it feels like. It does feel like this wave is kind of, just tumbling over itself, and the exact dynamics of that matter less.
Alphabet sometimes feels like living in the future, which is great in every sense that you can imagine, but can also feel a little bit overwhelming in the sense that, you have a model, people in various places are doing domain specific continued pre-training, or they're optimizing it in some way, or they're continuing to train it so it gets bigger and bigger and more impressive, all of the things. But you wake up one morning and you're like, oh my gosh, like this one version just surpassed human level performance on this thing that we thought that would not have human level performance for the next year and a half. And then, you go to your next meeting and then you look over and it's like, oh my gosh, like this just hit, 10 full percentage points higher on an eval just by adopting this one particular approach. Or like, oh wow, like RLHF moved the needle 25% or whatever it might be. So it's just constantly kind of learning and experiencing these new things. And I have never felt like the pace was so sort of somehow accelerating still, even though it felt like it was a sprint. It's basically been a sprint since like December of last year, honestly. I am so excited. I don't feel tired. We probably all should feel tired, but like I feel so excited.
Yeah, I'm in the same exact boat there, honestly. For the last really 2 years since I kind of became obsessed with all this stuff, I have, in some sense, been working harder than ever. And in some other sense, I feel like I've had less trouble getting in gear than maybe ever before, because I'm just inherently super motivated and curious to learn, what the next thing is that I can learn. I'm really interested in this phenomenon, though, of these kind of surprising moments of advance or threshold passing. One of the most interesting results I've kind of gone back to over and over and over again is the grokking phenomenon. I'd love to hear a little bit more about this kind of, sounds like surprising, and kind of unpredictable and maybe even sudden, advances in capability. That seems to me like a really important question for the future of hyperscaling. We can kind of predict the loss curve pretty smoothly, but we can't really predict when different capabilities will come online, or even if they will, or even really tell most of the time, like, is that something that has really generalized in some meaningful sense or grokked in some meaningful sense? Or, are we still in kind of stochastic parrot mode or somewhere in between, a hybrid? I'd love to hear more about how you think about that, having kind of, had the inside view of watching the loss curve drop and seeing where there's also these like periodic spikes in individual specific capabilities.
At the most recent ICML, there was a workshop kind of related to this around reasoning, which I strongly recommend checking out. It also had a really powerful panel with Sammy Bengio and some others kind of walking through. There are papers that have proliferated with assertions like, oh, wow, GPT-4 can reason, or like this model can reason. And, we've unlocked it, guys, we've solved it. The reality is that when you actually start probing a little bit deeper to check to see that, there are these canonical examples, like you have 5 blocks on a shelf, you want to move them around. If you even just slightly change, it's not blocks anymore. It's like cheese and an apple and like all of these other things. And you change the terminology around like moving them around. Then suddenly you realize like the model isn't like, it's not reasoning at all. Like, it hasn't learned anything to that effect. It's just learned kind of pattern matching based on things that it's seen in all of the web pages that it might have explored as it was being trained. So I do think there are still certainly some capabilities that we're not close to unlocking. And then there are others where you experience these capabilities that you would have never imagined just by virtue of the kind of data that you might have incorporated into pre-training. So examples of this might be, for source code, including source code, but also including diffs data, or including perhaps commit messages whenever somebody was making a PR. And then suddenly, by virtue of having those data in various formats, you can ask the model, all right, well, tell me what I would need to do in order to make a performance fix to this code, or tell me what I would need to do to sort of migrate this code from one API to another, or one dot release for an API to another. And those aren't things that, somebody could sit at a computer and make an exhaustive list enumerating potential capabilities of the model before it gets released. It's all stuff that we find out kind of after the fact as people kind of test it, and then sort of see what it does. Like there was another really compelling example just recently where we introduced new lens capability within Bard. Someone decided to do the test where they sketched out something like the design of a website, and they fed it into Bard, and they said like, hey, could you generate the code for this website? And then Bard was able to do it. Like whenever we were introducing lens capability, we did not think like, oh, wow, like I bet you it can like take in images and generate websites. It was just something that was kind of observed. Honestly, that's super cool. Like, and it means that all of the people who are testing the limits of what these models can accomplish, and who are so creative and like pushing the boundaries, you're all kind of helping accelerate research and helping us understand what we need to do in order to make these models better, how we should be evaluating them, and then also sort of imagining even other tasks that they might be able to accomplish over time. So it's really cool for people at home. If you don't realize it, like every single researcher in the world is tied at the hip to social media, just kind of seeing all the cool stuff that y'all do. And that's all going into things that we need to do to improve the models, how we might be evaluating them, how we might be improving instruction tuning, and then also, the kinds of data that we should be generating in order to kind of improve those capabilities over time.
I love that call to action for people. And I'm totally with you in that it feels like the need for kind of citizen scientist LLM explorers is huge. And I really encourage more people, if they have the curiosity, to go for it. It's really not that hard. In today's world, you can actually make meaningful discoveries right from an interface. And with, a little bit of code, you can, start to characterize that more systematically. And before you know it, you've got something that is meaningfully contributing to the global understanding. And, there's a lot more global understanding that we still need. So I definitely appreciate that encouragement for the audience.
Especially multilingual examples too. Like one of the other, you asked about a cool thing that we saw with PaLM 2 whenever it was first created. One of the engineers on our team, Rohan Anil, who is also very much obsessed with code, so it's not just me, he tested out a situation where he asked the model to generate some code and then to explain each line of code in line, but using Malayalam. So using a different language, and it was able to do it because we had kind of integrated multilingual capabilities within PaLM 2 as well. So that was something that was super surprising, majestic to see.
Yeah, it's a great word. OpenAI has said something similar where in their original instruct paper, they basically, as I understand it, only used English instructions. And then they were kind of surprised to see that it handles instructions in a lot of languages. So I want to just go back to the reasoning, grokking, statistical correlations concept for a second, because it's still pretty confusing, right? There's like some things where it definitely seems to be doing some reasoning. Maybe you would say, no, you don't buy that at all. It's hard to believe that all this stuff is just purely paratree. How would you if you had to give a very short summary for somebody who is going in and trying to do some of this exploration, how would you orient them to what kinds of reasoning or the degree to which there's reasoning? And how do you know when reasoning is kind of stopping and you're just entering into, statistical noise that may be confusing or could confusingly like reasoning?
That's an excellent question as well. How do you kind of spot when a model might be fibbing or when a model might be sort of presenting itself as having the ability to reason, but not necessarily having the capability innately. And I strongly, strongly recommend watching that panel session. Particular, there's an additional talk from the same workshop called "Avenging Polanyi's Revenge," which also quite gets into this. And it's a way to kind of take a step back and be a little bit empirical about testing these capabilities. Because the likelihood is that, as an example, again, the blocks on a shelf problem. Usually these questions are kind of formatted in the same way whenever people are testing out ability to reason. It feels a little bit like SAT or ACT questions. So they've all been kind of crafted in the same format with the same words, the same entities. Just as some people get really good at taking standardized tests, the model gets really, really good at sort of giving the impression that it knows how to reason and knows how to move block around on a shelf to solve a user's problem. But the instant when you say, like, no, it's not blocks, it's something else, it's not a shelf, you're actually putting them on the floor. You're not trying to move them around, you're trying to put them in different locations in space. Then suddenly everything falls apart. And it's because this is still a reasoning problem. It's just outside of the context space that the model understands. And that means that, the model is just kind of reciting things that it's learned by rote. It isn't necessarily kind of building the skills it would need in order to sort of take what it's learned and apply it in a new context. Just as you might have kids that are, or not kids, like just humans generally, I guess, that are really good at memorizing things, but not necessarily taking what they've learned and applying it in a new context. There was another really excellent takeaway from the Avenging Polanyi's Revenge talk, where a paper was sort of proposed saying that the models took so much prompting and sort of correction in order to get the correct answer for reasoning. Like some grad student saying like, oh no, that's not what I meant. Like you should do it this other way. That the author proposed that the models are limited only by like what the grad students knew. So like if the grad students knew how to accomplish a task, then they could prompt and kind of nudge the model towards whatever outcome they desired, which isn't necessarily empirical and isn't reasoning. It's just kind of keeping course correcting the model until it gets to the right location. That's still powerful, that the models might be able to arrive at the right destination, but it's not sort of getting them there by themselves.
Yeah, I'm kind of obsessed with this question right now. So how do you understand when you see a phenomenon like that where it can do apparent reasoning and then with a perturbation it kind of can't do apparent reasoning anymore? Do you think that internally that is like, because you can imagine different explanations for that, right? One would be it's all just pear tree and here the correlations worked out and here they didn't. Another one would be there is actually some reasoning ability, but there's like, a sub-circuit that is doing that is either, getting activated or not activated depending on a context, or, maybe is getting activated but drowned out by other noise. Do you have any sense for how to conceptualize what's going on inside? I mean, I know that's tough because we're still collectively working on cracking that, but I wonder what your, best guess is right now.
I unfortunately have very little domain expertise in that space. I do know that that people are thinking about it very carefully, both by building tools such that we can see what portions of documents are useful as models ask questions. So Anthropic had a recent paper to this effect, where you can see from either the pre-training corpus or from something that you might include in the context window or in the prompt, what particular words are most important and what placement of words are most important for the model to make a decision. When you think about applying that at scale, everything gets very tricky. But again, I'm not an expert in this space, so I would not be able to give you a great answer. I would say that if you want to talk to some of the folks at Anthropic, They have amazing intuition. In addition to the folks at Google DeepMind, it's a challenging space. Like reasoning is the thing that everybody seems to be like pushing towards. Like, how do we plan? How do we reason? How do we break down this higher level problem into steps? And then that kind of gets you, the holy grail for these like general autonomous agent things is like, how do you go from having a natural language problem to decomposing it into steps and then like generating code to accomplish tasks or like doing retrieval lookups to accomplish tasks?
I don't think anybody in the world has a definitive answer on that. Even, Anthropic, if I heard Dario the other day, and it sounds like they've got still more questions and answers too, which is
amazing. Like it, and that is again super exciting. Like there's never been a more interesting time to work in computer science or work on AI. And if anybody tells you that they've got everything figured out, then they're probably not. They probably haven't looked in enough locations yet. And like the number of interesting problems to work on only seems to be growing.
I think you recently tweeted that Palm 2 is now in 38 products.
I don't have the exact number for you, but it's certainly in more than 38 products and features. And it's also been deployed in a very variety of sizes. We touched on this externally, everything from small enough to fit in a mobile device to so large that you have to serve it on a cluster of machines. So it's been really, really energizing to see all of that great work happen from so many people.
So what are the products that you are most excited about that you think, people should definitely go try?
One of the projects that I'm driving at Google DeepMind is our Code AI effort, which is a collection of about 150 plus researchers and engineers that are working on everything from code generation to code explanation to security vulnerability detection to automatically applying performance fixes to source code migration to generating source code to interact with tools and APIs dynamically. And being able to do that kind of general purpose autonomous agent thing that I mentioned before, which is you have a high level task, you can decompose it into steps, and then you can sort of stitch together code in order to kind of navigate to accomplish tasks to assign yourself new tasks. So lots of really interesting work. In this vein, so we have a product called Cody, which is sort of Palm 2 with continued pre-training on a lot of source code. This is offered as an API through GCP. I think a number of companies are trying it out to see if it would work for them and for their IDEs. So if you're interested in code completion, code explanation, all of these things, certainly give that a go. We're also, we announced this at I/O, Duet AI for developers. So integrating machine learning models across the entire spectrum of GCP products. So generating code within an IDE, but also the security vulnerability detection, doing kind of rigorous analysis through logs, helping with DevOps activities, doing autocomplete within the Cloud Developer Console, some sort of Q&A that can help you navigate Cloud Developer Consoles because they can get a little bit overwhelming with the number of products that happen to exist, automatically generating architectural patterns, all of these things. That's particularly exciting. I would also love to have people kind of explore things like MedPalm. The team has done amazing, amazing work. And there's tremendous potential in the field of biosciences and all of the sciences, really, for these large language models tools and also for code generating tools. I feel like most scientific progress now is limited by the reality that physicists, biologists, chemists, etc., most of their day job now is like, I have all of this data. How do I munge through it? And they should not be expected to have PhDs in all of their respective disciplines and also a PhD in computer science in order to be able to further their research. So super, super excited about coding tools also being useful for these scientists. And machine learning has also been integrated into Colab for Colab Pro Plus users. So the Cody API that I mentioned before has been kind of introduced within Colab to support code generation, code completions, as well as code Q&A. And I believe error fixing is on the way.
It's quite a portfolio. I definitely think the cloud one in particular, I mean, all of these are powerful, obviously, but one of my big theories is that any giant, argue possibly could describe as, way too complicated, bloated, overfeatured, impossible to navigate. And by the way, no slight on Google Cloud, like all the clouds, there's a bazillion features on all of them, right? It's a lot. I think those are products that are going to stand to benefit the most because nobody can figure that stuff out, or nobody who's new and just like stumbles into Google Cloud today has a great time, I don't think, of like figuring out what they need to do with it. And this AI layer to kind of smooth over all of that and like gently guide you toward the right place. Boy, I can remember times I've needed that. Really interested in your thoughts on where the next leaps are coming from. You mentioned multimodality, obviously being a big part of what Gemini, the next big release, is going to bring forward. A couple other things that I would love to get your thoughts on. We recently saw this tree of thought paper, which to me kind of suggests that maybe there's a like deep mind brain, obviously there's a literal organizational fusion, but it seems like maybe also a fusion of approaches coming where some sort of planning algorithm natively combined with the more fluid ability of the language model. Is that something that you're expecting or excited about?
There is tremendous potential when you sort of get clever about when you call models or when you're using the capabilities of a large language model, whether it's for code generation or for answering in a natural language way with other sorts of tooling or other sorts of software engineering in a performant way. So a way in which this can manifest is, and there have been papers on this externally, but something called execution feedback. So like say your large language model, you give it a high level question, it generates some code. You can check to see if the code is actually valid. And you can even use like a large language model for this, or if you're like wanting to be a little bit more efficient, you could just use static analysis tools. You can run the code. You can check to see that the output accomplished your task. If it did not, you can kind of recursively apply the model such that it fixes the code before it runs again, outputs an answer, and then you can verify. So that's not like saying, hey, model, like just keep going. It's actually trying to stitch these things together in a really efficient, kind of clever way. And then over time, if you have enough of those instances, so like the execution feedback with the model like transforming its stage, then you can just incorporate that as training data, and then the model understands it anyhow. But in the interim, like this kind of process of, it's not just the generated pieces from the large language model, it's also the bits of feedback that you get, not just from humans, but also from compilers, from execution, from all of these other aspects. I'm super excited about that. That's the only way to get truly powerful systems.
Curriculum learning came to mind because I noticed you said that Cody was like continued pre-training on code. I think OpenAI has said that their like instruct models were, intensively pre-trained on code. Seems like there's a lot to unlock there. And then also just wondering if you're expecting a successor to the Transformer anytime soon, or if that seems, impossible to imagine.
I would not be surprised to see a successor to the Transformer. And I know a lot of very brainy people are thinking about it, both at Alphabet, but also external to Alphabet, like Noam Shazir. Immense respect for him and the Character AI team. And to the curriculum learning piece, we did see tremendous gains when doing continued pre-training on PaLM 2 with code, not just at code tasks, but also, at math, at logic, at natural language even, so much so that there's a good indication that the more source code that you include in pre-training data mixtures and the more math style data, the better it gets at all the things. So that's definitely something that I would encourage people to test out is, as you're doing continued pre-training, if you see that certain types of data or certain kinds of data quality dramatically impact your downstream evals, that's something to consider incorporating heavily or heavily weighting in the pre-training data mixture.
Paige Bailey, thank you for being part of the Cognitive Revolution.
Thank you so much for having me. This has been fun.
It is both energizing and enlightening to hear why people listen and learn what they value about the show. So please, don't hesitate to reach out via email at tcr@turpentine.co, or you can DM me on the social media platform of your choice.
OmniKey uses generative AI to enable you to launch hundreds of thousands of ad iterations that actually work, customized across all platforms with a click of a button. I believe in OmniKey so much that I invested in it, and I recommend you use it too. Use CogRev to get a 10% discount.